And now let's discuss about the common, the default DSCP values that's been set for OSPF. So now let me open up the slide. It will help you to understand even more better. So if you look at this, so is there congestion on your network? So as I told you, your QoS will only be applied if there is a congestion. Otherwise, there is no priority. It just works like a normal traffic that's traversing between source and destination. So is there a congestion on your network or in your internet egress? Is the traffic going out? Yes, QoS DHCP will help you out with this. So is there a connection on your, is there a congestion on your wireless network? Yes, QoS will be applied here. So are your LAN switch port set up to support QoS and respect app-based QoS DSCP marking has been done? You can mark your application something like this. So this is my voice traffic. So the DSCP value is 46. And if it is a routing, my DSCP value is 48. And since it's a video conferencing, 34. So you have to look at this TOS bits. This all DSCP comes under the layer 3. And the COS comes under the layer 2. So mostly people, they use DSCP, so layer 3. And based on this, you can make use of this header information. So whatever the DSCP value you see, that exactly matches your AF values here. So QoS definitely helps. So your wireless environment setup to support QoS and respect app-based QoS, you should do your DHCP marking in layer 3 header. See, if your LAN switch port setup to support QoS, no, then QoS will not help. So if you apply that, yes. Is your congestion happening? Yes, and your QoS will help you. If you're not applying your QoS, it will not help you out. So this is legacy old model of saying it's a TOS. It is in the IP header. Let me show you the IP header for you. Okay, here exactly the TOS fits in. It's an 8-bit value here, TOS. But in the Wireshark, you'll see the differentiated service bit, that is DSCP value, you will see there in Wireshark. So from the IPv4 perspective, it is your type of service is 8 bits. You can see here the TOS is further classified into DSCP. So we got this DSCP IP precedence. The IP precedence is how I'm going to apply this QoS and how it is taking a precedence over the other traffic. So if I say it's a Teams, and if I mark the traffic with the appropriate values, whatever given for it, so I'm giving a precedence for the Teams traffic rather than all the IP traffic. So my precedence always goes for Teams traffic, then comes the next traffic here. So this is purely layer 3 TOS. So if you look at this in the IP packet, you see this TOS field here, TOS bit. And it is an 8-bit value, and the first 3 bit is a precedence. There you mark your traffic and based on the type of service you have. So this is a precedence number. So if it is all zeros, that is routine. And if it is marked with 001, it is a priority. So you don't want to much go deep dive about it. So the ideology is what is TOS bit and what is differentiated services and how the switch is going to look at it. So this is called the very important field you should see in the Wireshark is a code point. So that is per hop behavior. For every hop, this is applicable. The code is similar to precedence that we used in TOSPite. It is used to set a certain priority for a traffic. So nothing we're going to discuss more about this. So the ideology is something how my QoS helps and what is DSCP and how exactly I can see that in Wireshark. So you can leverage your understanding with this, with the multiple implementation, multiple designs. So now let's go back to Wireshark. And I'll explain. So what kind of topology is this? I have built a simple topology. Let me open up this. So my fast Ethernet 0/0, I have assigned the IP address 192.168.34.3. And in router 2, if you look at this, show IP interface brief. So I've given 192.168.34.4, a point-to-point connection between this switch and the router. And both my line and protocol both are up. So my connection is good. So how I'm going to apply the policy. So I'm saying here, so by default, the key thing you have to know is the SYN wait time is 5 seconds. You can tweak your values. So based on the devices you use. So if I send a SYN and I'm not getting a reply back, it will wait for 5 minutes. Sorry, 5 seconds. Sorry. And if you look at this ICMP, this is a class map. I have to use a class map on policy map. That's really going to define. So the class map, the policy map is the hierarchy and the class map comes below that. So class map, I am saying that match all your own predefined name you can give for your class map. And I'm saying this match access group 100. And I'll show you what is the access group 100 I've defined. Show IP access list. So I'm saying the traffic from 192.168.34.3. So between 192.168.34.3 and 34.4. So if you look at this, I have applied the service policy here. So this is a policy you have to bound to your egress always. So service policy outbound. And I've used a class name priority here. So run. So for my GRE tunnels, I have applied QoS pre-classify. That's something you have to treat my QoS before the IP precedence. I mean, before you look at the IP header, so I want my QoS to be applied before that. That's actually a very good way of doing your tunnel. So most of the time I have seen people, they apply QoS pre-classify for it. And I have applied in my tunnels. So before encryption, my QoS will be applied here. That's the meaning of QoS pre-classified. And if I want to check my config, show policy map, interface fast Ethernet 0/0, that is my egress. And you can see the class map, ICMP, and I can see 39 packets. This is all other packets. But whatever the IP that I have allowed in the access list, that's going to be applied for my QoS treatment here. So now let me generate a traffic, show IP access list. If you look at the values, it's 39 packet. And this packet is increasing for my class map. That is 44 packets. My tunnel is down. If I give debug tunnel on both ends, so now I'll generate a traffic here. So I have to ping the other end, the tunnel that is 24.4. It is tunnel is down. And let's start the capture. So it says OSPF multicast address I'm trying to reach. I'm going to bounce this tunnel. .4. If I ping the other end of GRE, it's 192.168.24.2. Going to this router. If there is fast, sorry, not fast Ethernet 0/0, it's tunnel. Shut, no shutdown. The phase tunnel 1 shut, no shut. So the tunnel is up. So I cannot ping. So now let's go one by one. So let's see what is how I can differentiate the how now Wireshark differentiates the traffic. the QoS traffic. So from the reachability perspective, let me ping show IP interface brief. To do a ping, I can ping. Where's my ICMP? Capture seems to be not working properly. So if I go back and do a ping, okay, I see the ICMP packets. So let's stop here. So if I look the ICMP packet, the DHCP value is a default 0. If you see, this is differentiated services field, and it is set to 0. And if I look at this OSPF, it says it is class selector 6. So the appropriate DSCP value is 46. Sorry, 48. The DSCP value is 48. So I can see the same in Wireshark here. The class selector is 48. If I go to ICMP, it is default 0. So what happens when there is a traffic, if it is an ICMP and if a traffic is for OSPF, that OSPF taking the precedence based on the marking, because I mark this traffic, it takes a precedence over the normal ICMP here. And the same way, if you apply for your DMVP and other stuff, and if you apply your QoS pre-classify, you see the GRE tunnels and EHRP takes a precedence over it. So where is the key thing we have to look at is the differentiated service value you have to compare. So here it says CS6 and 48. And for every protocol and every traffic, there is a DHCP value. As I told you, for routing, it is 48. And we are doing this OSPF routing, and it matches 48 here. So with a given link and how this congestion avoidance is happening, that's how the QoS helps you. And if you want to check is that your QoS is properly applied, so you have to do show interface, the respective interface. If you see, the queuing strategy used is QoS pre-classification. So it takes the precedence here. Show policy map. Interface tunnel 1. I haven't applied any policy in tunnel 1. Show policy interface fast Ethernet 0/0. It will show me I am matching the traffic only for ICMP. And it is not taking any precedence here. But when the OSPF packet's been exchanged, it's not even looking my QoS, but by default, the QoS has been marked. So when my packet, OSPF packet that's been egressing from my device to other remote device, so that's been marked with DSCP value 48. So this is how you can do it. So it's simple lab. So this is a configuration I have for this pre-QoS. So example, you work for Tata service provider and you are offering connections to customer with QoS guarantee. Once your customer wants you to create a tunnel interface, but they're also using a number of application that requires a low latency. Can we see how we can build a connection? So your application and everything that comes on the layer 7. So how I am going to, give a guaranteed QoS for my connection. So you have to apply a policy. The same thing what I did is I have to apply a service policy on the router with the priority on for only for ICMP traffic here. This is for demonstration, so we are not doing much, but the takeaways where exactly it should be applied. So the QoS pre-classify is applied on the tunnel interface for the better application response, better performance for your applications. And also for testing, we applied the ICMP policy for QoS. So this is about, QoS and what is the use of QoS. And if you see most implementation in the Junos boxes, they will use precedence value, that is a DHCP bit to allow prioritization of OSPF messages or control plane traffic. The Juno sets all the OSPF packet to precedence 110 or CS6. And the same thing we have seen, we also Cisco boxes, they use CS6 for it. This is default. And with this link, you can do a deep dive about how the other classification and marking works. So the DSCP is advanced version of TOS. And we have seen how we can, the Wireshark is interpreting the values here. And there is an option for GNS. I'm trying to find hard time in fixing this, but ostinato with Wireshark is something you can generate your traffic in Wireshark. I think it has some bug, so I cannot run this. Let me stop this capture and try. Yeah, I haven't run my GNS VM. Let me go edit preferences, GNS VM. Let me turn on my GNS VM. So I think the memory is very less. Let's see, we can establish a connection with it. It's not working for my keystrokes. I'm waiting for, I think the device booted, but I don't see that here. Edit preferences, GNS VM. So my connection is huh? Yeah. If I have to start this, I have to take a console. So right now I'm fixing this. So with this application, you can generate different types of QoS traffic. So you have to configure the streams to do it. It's very slow. I'm trying to fix this. So from this, if you have a connection to your switch and if you apply some QoS and you can actually test your connection, is it my DSCP values that's reflecting in the Wireshark? Whatever the config I apply for the specific, you see this goes down. So you can play around with this ostinato. So I'll give a documentation how exactly I have done this. So I'm going to shut down this connection. You go to ostinato traffic generator. For Wireshark. Yeah, we have to go to GNS3 marketplace. And here is the link. So there's no much instruction I have given. It's given here, but all you have to do is, this is pretty straightforward. Once you download this, you will get a template. Ostinato. This is my ostinato. It's my downloads. So edit file, import appliance. Okay, we'll do it and I'll download and do it. Again, so let me go back here. So we have to download this template. Okay, it is in OneDrive PCAP. So file, import appliance. I have to go here and I have to go to the template file, ostinato. I have to click on it and open. So it will say you have to install this in a GNS VM. So the template will be available in the guest category and finish. So it's already been used. If not, you can click finish. And you'll get your ostinato below this devices, the list of devices, PCs and firewalls. You'll get this ostinato Wireshark appliance here. Then it's pretty straightforward. You can add it. You have to, your GNS VM has to be powered on and you can drag and drop here and you can start and doing it. And it will use the VNC terminal. So from there, you can access it and there is a very good document I saw here. So here you can go through the slides to use this particular tool, features and documents. I share this to everyone, chat. So you can play around with this, and I'll also try to fix it. So there you can generate multiple QoS traffics. When you apply based on the QoS policies, you can you can generate the QoS traffics, and you can see the same in the appliances, whatever appliance you use, you can see that. And now let's jump into the other key features that is helpful in Wireshark. So let's see what is protocol hierarchy first. So if you go to statistics, the third option is protocol hierarchy. So if you see what are the protocols I'm running now, I'm running OSPF. I'm running my IPv4. If it is an IPv6, it's going to say IPv6, and the actual data is this. And I'm using the loopback adapters here, and I'm using OSPF. So if your CPU is consuming a lot in your boxes, and if you see what is the top protocol that's being used in your router, so you can take this dump cap and you can actually compare. So what is the amount of traffic that's been sent, this percentage. So 26% out of 100% is 26% my OSPF traffic is consuming, and 52% my internet protocol is consuming here. So you can also see here the data is just 21%. So here you can see your actual IP packets has been going back and forth, and your OSPF communication is really good and it is increasing. And you can see your ETH layer 2 information with the protocol hierarchy. So it's pretty handy to use it. So what kind of protocol? If you use GRE, it shows up GRE, and if you are using BGP, it's going to show it as a BGP and EIGRP. So you will have a bird's eye view of, okay, what are the protocols that's running on my appliance here. So the final thing is TCP flow graph. So you have to go to statistics again, and you have to click on flow graph. And if you look at this, the key thing you should look at is where the communication is happening is between 192.168.34.3 and 192.168.34.4. And it will show the same thing in the Wireshark where exactly your packet is. So here is your packet. It's highlighted in the background. So you see this is an ICMP ping request that is coming from 192.168.34.3, and that goes to 192.168.34.4. So I got a ping reply back with TTL. And if you see all this as this communication, it's a differentiation. This is one ICMP, full ICMP. For my ping request, I get a reply back. You can use the identifiers to classify the same. And if you look at this, so my appliance is sending a hello packet to all this OSPF multicast address. And the hello packet's been sent from this device 192.168.34.4 to the OSPF multicast address here. So in turn for this hello packet from 192.168.34.3, I receive the hello packet back. So I see hellos, and definitely OSPF is running on it. And if you want to limit to a display filter, whatever you apply there, it will be applied based on your display filter, whatever you want to apply there. If I want to apply only for this particular IP address, you can go to statistics, flow graph. You have to click on limit to display filter. So I see only the hello packets. So from 192.168.34.3, I send hello for this OSPF multicast address. And then the same, in turn, it sends an hello packet back. So you can also classify your TCP, UDP, TCP flows, ICMP flows. So there's no TCP flow. So yeah, I have given all flows, and any address is always recommended to use it. So This particular flow graph helps you to have a complete visual of, okay, where exactly my packet is traversing. Am I getting a ping reply back with more visual? And when we look for OSPF, it shows more details about OSPF. And if you use GRE and your other protocols, you'll get to know the complete insight of what exactly happening between source and destination. And if you click on a particular packet, it's actually highlighted back the Wireshark. So this is about TCP graph. Sorry, it's about flow graph. And you see the TTL values and everything's common we have seen. So you can make use of it when you do a troubleshooting.